Hello and welcome to MapleStory World. Today we've got something special in store for you. We're going to be walking through the inner workings of a side-scrolling shooter template world. This template will be more so an introductory project intended to provide you a kickstart towards development of a world in the side-scrolling shooter genre. Today we'll be diving into the codebase of this template and help you to understand the inner workings of this code. There's a lot to cover here today, so I'd suggest rather than attempting to digest all of the information presented here in a single sitting, take time to review the various topics we cover piece by piece and return to the relevant timestamps as you explore the project on your own. By the end of this video, you'll have the understanding necessary to start adding your own unique ideas and unique talents to expand upon the systems that we've built for you here. And with that, let's take a look into what we'll be diving into today. Here we are in our shooter game framework, and before we press start game, let's first learn how to play. So we'll click on the how to play button, and we can see that our movement is bound to WASD, and we have our attack bound to J, and we have our skill bound to K. So with that in mind, let's close this window and let's click start game. And here we are presented with our character selection screen. So at the moment we only have one, but we've built this system in a way where you can add your own different characters if you'd like. And of course, this will require some coding on your end to develop and flesh these characters out. But for now, let's click our select character for our pirate, as that's the only option we have. And we're hopping into the game, and WASD to move, J to shoot. And K for our skill. So K is a little bit overpowered, but also notice that we have items dropping as we defeat the enemies, and we have our life pool as it decreases. And when we use our skill, the skill is also going to be decreased as well. And we have various items that will increase or decrease these values, and it'll also increase different values such as our movement speed and things like that. So if I click retry for just a moment, I also want to showcase the manual versus auto fire settings. So if I click on this button here, we can see that we are now firing automatically and I don't have to press the J key to fire. When we take damage, notice that after the first time, we don't take damage for a little bit and then we can take damage again. So we have a little bit of invulnerability time. Okay, so that's the world that we are going to develop, or at least take a look into the code of how this all works. The very first thing that I want to cover is actually the map layout. So if we hover over this icon up at the top, we can see that this toggles a tile editor. If we click this on and click on our map, we can see that we can draw tiles into our map. If we click and hold this, we can see that we are currently in the rectile mode. So we have three different modes to choose from. We have our maple tile, rectile, and side view rectile. Each of these will have a slightly different view, and we do cover this in the introductory promo tutorial series, and I highly encourage you to review that video if you don't really understand the nuances between these three types of maps, but we are utilizing the rectile. And if you're not quite familiar with the rectile mode, let's quickly do a recap of our rectile mode and how things work. Okay, so I've created a new project here, and notice that we are currently in the maple tile mode, and we can verify this by clicking and holding this, and we can see that we are indeed in the maple tile mode. So from the maple tile mode, we want to switch to the rectile mode. So let's click on a rectile, and we're going to be cautioned that our current tile setup is going to be erased, and we don't care about that, so we're just going to click on yes. And immediately you can see there is this kind of brown background that we start with, but we don't want that. We want to have a kind of a sky background. So let's click on the background here, and we can choose the type. So at the moment it's in solid color, and we can change the color of this to whatever we'd like, but that's not quite as pretty as the cloud background we had. So let's change this from solid color to a template, and this will allow us to use any background that exists in the MapleStory Worlds library. So let's click on the template RUID, and we have a lot of different backgrounds to choose from, but let's click on the sky background as this makes the most sense for our bullet hell game. Now we have our background, but if we'd like, we can choose to paint our tiles into our grid. But at the moment, we can't do so, and this is because we don't have a tile set yet. So if we click on the plus button here, we can choose from a pre-existing template, or we can create an empty tile set and we can upload our own assets to draw onto our screen. But for now, let's just stick to our default Hennessy's, and we'll name this my tile set. And we can see that we have loaded in all the different tiles that are default to this tile set. So let's just click on any tile, and if we click on this paint box, we can drag across and we have our full tile set here. And if I press play at this point, we have the ability to move within our world. And if I were to click on the edit button and toggle on passability, I can choose to, let's say, toggle the passability of this tile off. And if I were to go back now and notice that our impassable tiles are now highlighted in this red arrow, if I draw this onto our screen, now there's this wall that we cannot pass. So let's press play just to test that out. And if I walk over, now I can no longer cross this border. And what we've done is we actually don't need a grid or tiles at all. So we can actually just disable this and just choose not to use a tile set at all. So if we press play, it still works. We're able to move and we're able to utilize and move around in our scene without a tile set. So now that we've done a quick refresher on the rectile mode, let's go back and do a little bit more understanding of the different components required for our rectile mode to work. Let's take a look at our default player here, and this is going to be the player that is spawned in for the local player, and it will inherit the avatar and the clothing, etc. for that avatar and the character when they load into our world. So they're going to have a ton of different components attached to them, and our player is identified as what is known as an entity. An entity is anything inside of our map that's present. So that includes the map entity itself, the entity housing each of our maps, all of our UI entities, etc., etc. Each of these entities can have components attached to them. So our default player has a ton of different components attached to it, and the most important of which will be our kinematic body component. So let's collapse all of our components here just so that we have a bird's eye view of all of our components. And our kinematic body component is what will work with our rectile map. So depending on the type of map that you have, the required component will be different. So let's do a quick refresher on entities and components and the various types of scripts before we proceed any further. So as I mentioned, an entity is anything that exists on the map. That includes the rectiles and the map itself. Everything that you see on screen, even things that you might not see on screen, is considered an entity. And each entity can have components attached to them that allow them to function in the way that we want. So we can see that this entity has a sprite render component that allows it to have a sprite rendered on the screen. We have a transform component that determines the position of this entity, and etc. A component, as I mentioned, is a script that can be attached to an entity and allow it to function. So to create a component, we can right-click on my desk and click on Create Component. That will create a script that is attached to any given entity. So a component is always associated with an entity. And it has both the benefit and the drawback of needing to have reference to this entity in order for us to reference this component. So for referencing and finding this component, we have to first find this entity or have a reference to this entity, and we can directly reference the components attached to this entity. A logic script, on the other hand, is globally accessible. So any script, any components can globally access this logic script. What this means is that we don't need to have a reference to an entity in order for us to access any properties or methods associated with this logic script. A drawback for this, however, might be that this can be easily abused. So remember that every script and logic, because it is globally persistent, it can be a memory eater. So be careful not to abuse logic scripts and only use it when you know that you have a certain method or a property that needs to be globally accessed. So I mentioned that each of our different types of maps, MapleTile, Rectile, and Side View Rectile, all three of them work with different types of components. So our MapleTile works with the rigid body component, our Rectile works with the kinematic body component, and our Side View Rectile works with the side view body component. So it's important to make sure that depending on which mode you are in, that you are utilizing the correct type of component. So for MapleTile again, it's rigid body. And if you were trying to use a rigid body component with the Rectile map style, it will not function properly and you won't be able to move the character properly. You won't be able to affect the character properly. You will have to make sure you're utilizing the kinematic body component for Rectiles. And for each of the respective types of maps, make sure that you are working with the proper component. So in our game, we're going to handle our code through what are called managers. Each of these three different types of managers, the game manager, data manager, and the UI manager, we're going to create as a logic script. And the reason for that is we want each of these scripts to be globally accessible and have these as the main kind of communication pathway between the core components necessary for our game logic to run or our data manager to run. So what are these three different types of managers and what are they used for? Typically in games, you'll usually see these three types of management systems in different forms. The game manager manages the core runtime logic, the data manager updates and retrieves data in game, and the UI manager updates the UI of the world. So again, these kind of act as bridges or pathways between the different components. So for our managers, we're going to have all of these created as a logic script. For our game manager, we're going to name this GameLogic. For our data manager, we're going to have our data table. And our UI manager, we're going to have our UI manage. Hopping back into Maker, we can see that we have our logic folder. In here, we have a manager folder, and we have all of our different logics in here. So we have our DataTableLogic, we have our GameLogic, and we have our UIManageLogic. And we're going to go through each of these in sequence to understand what these managers do and how they function and communicate with our different components. First off, let's start with the GameLogic logic script. And note that we are in local workspace, so we're going to be utilizing VS Code. So to enable local workspace, we're going to toggle on our local workspace and extended script format so that we can utilize our VS Code and code in there. Please reference our documentation for more information on how to enable local workspace in your project. So with that said, opening up our DataTableLogic script in VS Code, we can see that we have a bunch of different methods and a bunch of different properties. Let's take a look through each of these and try to understand how all of this is working. So our DataTableLogic manages data in our world, as we mentioned. However, we are not managing persistent data, meaning the data that you would save. We're instead working with our data tables that we see here. So if you double click and open up any of these, we can see, let's say for example, our character default data. We can see that this manages the character and the various information associated with that. Our data table logic is going to provide a method to load in our character data, cache that into our property, and then retrieve our character data later down the line based on our character's ID. In our onBeginPlay, we're going to load in our character default data, and that is going to grab our data table through DataService, and we're going to pass in the name of our table, which is going to be character default data, as we saw here in our character default data table. Then we're going to do a quick validation to check if our data table actually exists, meaning that we didn't spell this wrong or that our character data table doesn't exist. Then we're going to return if we've got invalid data. Otherwise, we're going to loop through each of the rows by using getDataTableData.getRowCount, and we're going to loop through the total number of rows. And for each row, we're going to use our getCell method to grab the cell and the column associated with that data. For example, in our character default data, we have our character ID here. Our code is grabbing the first index or the first row and grabbing the column information for that character ID. So in this case, that would be pirate. We're going to double check to make sure that that character ID is actually valid and it's not an empty string. And we're going to then load in all of the data and the rest of the data, including our start HP, start skill count, move speed, etc., and cache that into a new table. This is going to be another table that we're going to create called row data, and we're going to store each of these values into an entry into this row data. Finally, after we've crafted this new table, we're going to store that into our cached property. So this is up here, we have our property that is just going to be an empty table. We're going to cache this by the character ID and set that to the row data. And this pattern is going to be identical for all of the different data tables that we have. So for our CharacterSelectUIData, our ItemData, our ItemDropData, all of these different tables is going to be loaded in through our DataTableLogic and be able to be retrieved by the corresponding get function. Before we moved on to the next type of manager here, I did want to retouch upon the data storage systems and the distinction between the data tables we have here, which is intended more so as config files or definitions of various object info, stats, setting, and other pre-runtime data that can be easily changed down the line. These data tables are usually not intended to be variable or modified at runtime. Data storage, on the other hand, is utilized for storing and managing persistent data across multiple sessions and worlds. So while character default data is a data table, it would not be intended to store changes to this data or evolve with the player over time and across multiple sessions. This is more intended as a more config file or starting stats. Data tables, as we saw, worked through DataService and various methods such as getTable or getCell to retrieve information from our dataset. Data storage, on the other hand, utilizes the DataStorageService and the corresponding data storage type, of which there are multiple. Please review our video on data storage for more information on these different types of data. But it will retrieve the corresponding data storage type and allow data to be persistently saved in a database. So please understand the distinction between the two and what we are utilizing in our project, which again is data sets with data service as opposed to data storage service. Okay, with that out of the way, let's open up our next type of manager, our game manager, and double click to open this up. So our game manager is named GameLogic and is a logic type script file. And again, the GameLogic is going to manage the core functionality of our game, and because it's a logic type file, it's going to be globally accessible by the components that need to reference these. So let's walk through each of the functionalities of our GameLogic, starting with our init local player. So if you open up this function, we can see that as the name implies, we will be initializing our local player. So up here, we have a property reference to an entity called local player, and we want to store the entity reference of our local player. So our user service is going to be able to retrieve the local player by using this .accessor. This .accessor will always retrieve the current client's local player, and we're going to retrieve that and cache that into our property. Next up, we have a request character data init, and this is going to take in our class name. And inside of this method, we can see first we're going to do a quick validation, and it's always a good idea and good practice to do these kinds of validations just in case there's some human error and we pass in an invalid class name or an empty class name, or we don't pass in a class name at all, and we're going to make sure we handle these kind of edge cases. So validating your code is always a good idea. But regardless, we're going to be referencing our data table logic that we just looked at, and we're going to be grabbing our character default data by character ID method that we saw earlier, and we're going to grab our class name. So we're going to pass in the class name to this method, and we are going to store that in this property. Again, another validation to make sure that this data is valid. Then we're going to grab our local player reference that we just set. We're going to grab the PlayerState component, which we're going to get into in just a moment, and we're going to call the init player data method of this PlayerState component. Our local player is an entity, and because we have the entity reference, we can access all of the components attached to this player. So if we hop back into Maker and we take a look at our default player, we can see that we have this PlayerState component, which is going to manage things like our HP, the bullet or the missile, the character ID, etc., etc. And in this PlayerState component, there is an initPlayerData method that will take in this data and initialize all of these properties inside of the PlayerState. Moving on, we have requestTeleportPlayer and we have TeleportPlayer. Notice that our requestTeleportPlayer is in the client space, meaning that this will only be executed in the client's side. And we have a TeleportPlayer, which is set to the server space. The logic flow here is that first we call the client method requestTeleportPlayer so that from the server, we can handle the movement of the player. First, we're going to request the teleportation of our player. Then we're going to teleport the player on the server side. So our teleport player is going to use teleport service to teleport our player into the target map, whether it's the title map or the in-game map. Next up, we have initStage. InitStage is simply going to search for our MonsterSpawnManager, which is going to be, as the name implies, a manager that spawns monsters into our level. If it exists, then we are simply going to call start game on that MonsterSpawnManager. We're also going to call initData in our ItemHelper, and this is going to initialize the data for all of our items. And we're going to get into this also when we cover the items during the corresponding section. Next up, we have countKillScore, which is going to increase our local counter. So we have a property called KillScore that starts at 0, and this is going to keep track of how many enemies we killed in this game. So this is going to be our kill score, and if kill score is greater than our clear kill count, and that will be initialized from our init clear count, that passes in the clear count and sets this value. If our kill score is greater than that value, then we're going to set our isStillPlay flag, which is going to check if the game is still running or not, and set that to false so that other components that reference this property knows that the game is now over. Then we're going to set our needGameResult to true. So this is going to call a UIManageLogic and show ResultUI, which we're going to cover next. We also have our restart game method, which is, as the name implies, is going to restart our game so that we can play it again. So the first thing we're going to do in this method is we're going to clear our object pool. So if we scroll up to our clear object pool, we're going to grab our missile pool entity and we're going to call reset pool. We're also going to get our MonsterSpawnManager and clear all children in our MonsterSpawnManager. So this is going to clear out all the monsters in our map, and this is going to clear out all the projectiles in our map. So why do we name this a pool? Well, in our ProjectileManager and also in our items, as we'll see later, we are implementing a game development strategy called object pooling. And essentially, what object pools will allow us to do is to reuse the entities for our bullet projectiles. So rather than continuously spawning a new bullet every time we need it, we instead are going to be reusing our bullet entities over and over and over again. This will save our performance and reduce the amount of memory we're using, and also the runtime CPU cost for spawning in new entities into our scene. Object pooling is always a great idea if you know that you are going to be spawning large quantities of the same object over and over again, such as projectiles or items. So here in our clear object pool, we're going to grab our ProjectileManager and we're just going to reset the pool so that all of our active entities is just going to be reset back into our pool. Then we're going to reinitialize our stage and pass in the current stage name. We're going to request character data initialize based on the current character. We're going to call UIManageLogic and show the in-game method. And we're going to set our isStillPlay flag to true. And finally, we have our change need autofire. And this is simply going to set a flag, need autofire, and toggle it on and off. So the final type of manager to cover is going to be our UI manager. So let's double click to open this up. And our UI manager is going to be called UIManageLogic. And of course, this is going to be, again, a logic file. And this is going to allow us to call these various functions from outside the script from any component. So from anywhere, we can show and hide various UI in our game. notice that we have a bunch of these properties up here of the corresponding controller. So we have a TitleUIController that manages and controls the actual data and what is displayed within the TitleUIController, and we have a reference to that TitleUIController. So if we open up our init method, we can first see that we're going to find our TitleUI entity based on the current UI path, and we're going to grab the TitleUIController from that entity, and then we're going to set our TitleUIController property to that component. This will be called an onBeginPlay, and we can see the same pattern for our SelectCharacterController, for our ResultUIController, and our DefaultUIController. So all of these init methods will follow that same pattern. Next, we have the show methods associated with each of these controllers. So we have showTitle, which will be corresponding to our TitleUIController. So if we open this up, we can see that we assume we have the reference to our TitleUIController, and we're going to simply call the show method of our TitleUIController. And on our other controllers, such as the CharacterUIController, the ResultUIController, and the DefaultUIController, we're going to hide all of these. And a similar pattern is going to be for each of these, for showInGame and showResultUI. ShowResultUI is a little bit different in that we're going to pass in a Boolean flag so that our ResultUIController knows whether to show the fail message or the clear message. If it's clear, then we're going to play the victory noise. Otherwise, we're going to play the fail sound. We also have our update life and skill count UI, and this is going to reference our default UI controller. So our default UI controller controls all the default character-related UI in the game, and we're going to call our update life UI, and we're going to pass in the current life. And same thing for the skill count UI, we're going to pass in the remaining skill count so that we can update that corresponding skill UI. So if you remember from our GameLogic script, we had request character data init, which made a reference from our local player entity to the PlayerState component attached to this entity and called the init player data from the PlayerState component so that we can initialize our player with that data. If we hop into Maker, we can see that in our default player, we do indeed have this PlayerState component attached to it. So let's take a look into our PlayerState component and take a look at what it does. So let's open up our component script, navigate to the player folder, and double click to open up our PlayerState. So here is the init player data method that we saw in our GameLogic file. And this comes from our DataTableLogic by retrieving our getCharacterDefaultData by character ID based on the class name. So when we initialize our player with this player data, we simply are setting all of the values for each of our properties. So we have a property for our current HP, which will initialize our starting HP. We have our CanUSkillCount, which will be the number of starting skills that the player starts with. We have our move speed, which will determine the movement of our character. We have our input speed, and once we get the starting move speed, we're going to grab the movement component attached to our player entity, which will be this component right here that handles the movement of our character. So our input speed will determine the movement speed of our character. We have our current missile, which will be the player data's default missile, and this will determine which type of missile that we want to spawn. We have our character ID, which will be the character that we want to utilize, and in this case will be the pirate, as that will be the only character to choose from. We have our attack interval, which will determine the rate at which to spawn our missiles. We have our skill ID, which will determine which skill to spawn for this character. We have the starting position, which is going to be 0. We're going to update the UI with the HP that we got from our player default data. We're also going to update our skill count UI with the CanUSkillCount that we retrieved from our player default data. Then we're going to enable our character's visibility so that we can begin our game. Conversely, on begin play, we're setting our character's visibility to false because in the title screen, we actually don't want our player to be visible. We only want to activate our character once the game starts, and that will be here at the init player data step when we enable our character and set the visibility to true. Next up, we have our connect missile pool, and this is simply going to grab our ProjectileManager. and it's going to cache a reference to that ProjectileManager by referencing the entity and searching for the ProjectileManager component attached to that entity. And if we check our maker, we can see that in our game, let's switch to the game map. In our game, we have the ProjectileManager here. And we can see that our ProjectileManager is a component attached to this ProjectileManager entity. So that's what we're doing. We're going to search for our ProjectileManager and grab that component. Then we're going to set the alive status of our player to true. Next up, let's cover our onUpdate. And onUpdate will be running every frame, and it's going to pass in the delta, which will be the time in between frames. So we're going to do a quick validation check to make sure that we are still alive and the game is still running. And we're going to have our attack timer so that we can fire our missile on a certain attack timer. So if auto fire is set to true, we want to fire our missile automatically without the player needing to input to fire our missile. Then we're going to update our invincibility time if we have been hit. So if we've been hit, we're invulnerable for a certain amount of time, and our set invincibility time is simply going to decrement or check for the total invincibility time. And if our invincibility delta is greater than the invincibility time, then we're going to set the invincibility delta to 0 and set our invincibility status to false. And we're going to see when our invincibility is actually set when we get into our handle hit event here in just a moment. Next, we have our fire missile. And our fire missile is, again, going to have a couple validation checks to make sure that we can actually fire our missile and we're within the timer to fire our missile so that we can't just spam a bunch of projectiles. It has to be within the attack interval, even if it is not auto fire. Then we're going to double check to make sure that we have a projectile pool, because that is where we're going to be grabbing our missile from. So from our projectile pool manager, we're going to grab our missile through the getMissile method. We're going to pass in our current missile that we set from our init player data. We're going to do our validation check to make sure our missile entity actually exists. Then if it does, we are going to grab the missile component from that entity that we returned from our projectile pool manager. And then we're going to set the fire direction, the current player position, and we're going to craft our fire position based on our player position plus the fire position. And that will be this value up here in our property. So we are going to offset based on our current player position by X offset of 0.25 and a Y offset of 0.25. So from our player position, we're going to offset by our fire position amount. Then we're going to fire the missile in that direction, which is going to be to the right. We're going to set our isShotPlayer property parameter to true. And if you look at our fire missile, we can see that we have a parameter in here that detects whether this missile is shot from the player or if it's shot from an enemy. Then we have our fire position where we're going to start our missile from. Next, we have our fire skill, which is going to be essentially exactly the same thing, except instead of our missile projectile, we're going to be grabbing our skill projectile. And then same thing, we're going to grab our direction, which is to the right, and then set the fire based on the offset. And then from our skill component that we retrieve from the projectile, we're going to call our fire skill that takes in the fire direction and the fire position. And then we're going to decrease our skill count so that we have one less skill to utilize, and we're going to update our UI. Next up, we have our applied item, and this is going to allow us to apply the effects of an item that we collected. So when we defeat an enemy, an item will be spawned and it's going to scroll from the right side to the left side. So in our applied item method, we can see that we are accessing ourselves kind of like a table. So any instance of a component or a logic script can be accessed like a table in Lua. What we're doing here is we're basically grabbing our player state name and checking if that is nil. So target player state name is going to check for a given property up here, and it's going to check against whether or not this property exists. So this property can be accessed by the self using the name of our property as the key. So if this property does not exist, then we're going to return. Otherwise, we're going to pass in our value type, and it's going to be either 1 or 2 currently. And if it's 1, it's going to be a number type. If it's 2, it's going to be a string type. So if it's a number type, we're going to increment our property. And again, we're accessing this like a table. So we're going to grab this property and we're going to increase this value by the number value that we pass in. Then if the target player state name is going to be move speed, meaning that we're going to manipulate this property here, move speed, we're also going to update the movement component's input speed so that we actually increase the move speed and not just the value of the property. If it's the current HP value that we are modifying, then we're going to increase the property like we did up here, but we're also going to update the life count UI. Same thing for the skill count. If it's can use skill count that is being incremented, then we're going to update the UI for that. If a value type is 2, then we're going to set the corresponding property to the string value. So for example, if we had this character ID that was modified or the current missile was modified, then this property would be modified to be set to the string value that we pass in. And then finally, if there's an effect ID that's being passed in, we're going to play the effect through the effect service. Next up, let's go through a couple of the event handlers that we have in our player state. So first up, we have our handle entity map changed event. So this is the event listener that we are listening into the entity map changed event, which is fired anytime this entity changes a map. Let's say from the title to the game or game to the title. When we transition between our different maps, that's when this entity map changed event will be fired. So our entity map changed event has a old map and a new map property, as well as the entity that made the transition. So going back to our player state, we can see that we are grabbing the new map property and the name of the new map. And if that matches game, then we're going to perform a bunch of initialization steps. So first, we're going to set the visibility of our character to true so that we actually start the game. We're going to set the isAlive to true. We're going to enable the movement component. We're going to connect the missile pool so that we grab a reference to our pool. Then we're going to call GameLogic's init stage. And remember, this calls the MonsterSpawnManager so that we start spawning monsters into our game. If it's title, meaning we moved from the game to the title, then we're going to hide our character. We're going to set the isAlive to false. We're going to break our reference to the projectile pool manager. And we're going to set the movement component's enable property to false so that we cannot move our character anymore. The next event will be the handle hit event. And again, we have some validation checks here. We're going to make sure that we are still alive before we are hit. We're going to check for our invincibility, and we're going to check for if the game is still running. The handle hit event is going to listen in on the hit event, which is fired anytime we detect a hit on our entity. So this hit event is going to be listened in on from the hit component. So from our hit component, this is what fires this hit event. And we are listening in on this hit event. So when that event is fired, we're going to set the attacker entity to the event's attacker entity. And if we kind of peek at the properties, we can see that we have the attacker entity. We also have the total damage that was dealt. And we're going to grab the position to spawn our effect based on the attacker entity position. We're going to set our current HP to the HP minus the damage that was dealt. And we're going to play the effect from the extra property, which is going to be passing in the RUID of the effect that we want to play. And then we're going to update our UI with the current HP. If the HP is less than or equal to 0, then we're going to play the death effect because our player just died. We're going to send the need game result to false so that we show the fail UI, and we're going to disable our entity. Otherwise, we've been hit and we want to be invincible for a short duration of time. And again, in update, we make sure that our invincibility is deactivated after a certain duration. And then the final type of event that we're listening in on is the key down event. So this is going to be the keybinds that we have. So we have bound to our J key, the fire missile, so that we actually fire the missile on the J key. And again, we're going to do some validation checks to make sure that we only fire if the interval is valid and we are not auto firing. Then to the K keyword key, we're going to bind the fire skill method. So when this key is pressed, we're going to fire our skill. So we've got our player state component all set up now. But now let's move on to our monster state component. So while the player state component is attached to our player entity, our monster state component must be attached to our monster entity. But before we open up our monster state component to take a look at its contents, let's step back for just a moment and hop into our data table folder. And let's open up this data table here, the MonsterDefaultData. And if we double click to open this up, we can see that we have our information associated with our bat. So our first column here is the monster ID, and we can see that we have our monster ID as bat_1. We have our starting HP of our bat set to 20. We have our starting move speed set to 1.0, and we have our default missile set to our missile_bat that will be spawned at an attack interval of 1.0. So this default missile will be spawned every 1.0 seconds. This default missile entry here is referencing our missile data table. So if you double click to open up our missile data table, in our missile ID column, we can see that we have our missile_bat entry right here. And this will be the missile that we will be spawning in. So back to our monster default data, we have our missile_bat that will be spawned every 1.0 seconds. And here in this column, we have our model RUID, and this will be the model of the bat that we're going to spawn. Now, what is a model? If we open up our models folder, we can see that we have a bunch of these objects here, and they're basically entities that have been stored as a blueprint. These entities in these folders aren't actually active in our world. However, we can store references to these models in script so that we can spawn them into our level. And when they're spawned, they will have the settings and the values that we've set up in these components. So these essentially act as blueprints that can be spawned in our level. So we have our monster bat model here, and if we double click to open that, we can see that we have our bat, and from our bat, we have a bunch of different components here. We have our transfer component, we have our state animation component, we have the sprite renderer component, the movement component, etc., etc., etc. All of these components that we've set up with this entity is now saved in this file called a model. And when we spawn this model in, it will be spawned with all of these settings set up. So we will right click our monster_bat model. We're going to copy the entry ID, and inside of our monster default data table, we're going to paste this value right in here. And this is the reference to this model so that we can spawn this monster in. With that understood, let's review our data flow again. Now remember that just like our character default data with our character information, with our pirate and the starting information for our pirate class and the values associated, we have our monster default data, which will go through our data manager, which is our DataTableLogic. So if you double click to open this up again, we have our monster default data table here. And remember that we're loading that information in from our monster default data table here. So if you open this up, we're loading in that table and we're getting each of these cells, the monster ID, the starting HP, the starting move speed, and all of this. And we're going to collect that into a table and cache that based on the monster ID key. And of course, we have our get function for our get monster default data by monster ID by the monster ID, which will be this column and this ID here. And we're going to retrieve that table that we've crafted right here from the data table. And we're going to return that table that contains all of that data. So we have a way to load all of the data, and we have a way to get the data once it's been cached. So returning back to our model here, there's a couple things that I do want to highlight in this model that could be important for us. So first up, as we mentioned, because we are in rectile mode, we will be utilizing the kinematic body component. This, in conjunction with our movement component, will allow us to move this entity around. So if we were to use any other component, like the rigid body component, with the rectile, it will not work. So please keep that in mind. You do have to use the correct component with the correct map style. Next, we have the AI chase component. So the AI chase component is going to manipulate the movement component for us, and it has behavior to follow the player around. So we have the update authority set to client because we only want the AI to operate on the client side. And we've also checked the localized property of our entity. So if we right click and we place to our hierarchy, for this bat, we want to make sure that we are localizing this entity. So if we click yes, we essentially make sure that this entity only exists on the client side. So for our monster bat, we're going to manage this bat from the client side. and we are ensuring that this localized property is set to true. So let's delete this and let's hop back into the model to continue our analysis of the different components. So then we have our state animation component, and this holds a reference to the different animations for our bat. So we have our fly state, we have our hit state, and we have our die state. Each one of these has a different RUID associated with it, so that when we enter the fly state or the hit state or the die state, it plays a different animation, or it sets the sprite render component, which we'll talk about next, and set the RUID field to the corresponding ID so that we play the right animation at the right time. Then we have our trigger component, and our trigger component is going to set up the range that our monster can be hit by. So if we place our monster again, so let's right click and let's place the hierarchy. And if we edit the collider, we can see that we have this green box here that determines the collision area. So when we fire a projectile and we try to hit this monster, this collision area in this trigger box will be determining when the projectile and the monster overlaps. This range will be when we detect a hit. We of course have different types of colliders. We have a box, a circle, and a polygon collider, which if we set the collider autofitter, it will kind of create a custom collider to this shape, but this is not recommended unless you absolutely need that level of accuracy, because the more points and the more complex the shape it has, the more calculations that needs to be done. So let's just keep it simple. Let's keep it to a box, and we'll make sure that the collision range is appropriate. We also have a collision group, and this will be more important when we get to our attacks and how we deal and take damage. But our collision group will ensure that various collision entities only interact with the entities that we wanted to interact with. So if we open up this panel here on the right side, we can see a list of all the collision groups that we have available. This trigger component is set to the monster collision group. And if you check the matrix, we can see that in our matrix, we can set our monster to collide with different types of entities. So our monster can collide with a skill, and it can collide with the missile. A player can collide with an item, missile, or a monster. So in this way, we can set up our collision matrix to only interact and only be interactable with the collision groups that we set up in this matrix here. And then finally, we have our tag component that can be referenced by script to identify this as a monster. With that out of the way, let's now finally open up our monster component, and let's dive into what is going on in the code here. First up, we have our init data. So in here, similar to the player state where we initialize the data in our player state, and we set up all the properties based on the data that we passed in, we are similarly taking in the monster data, and this of course will be the data that we pass in for our monster data table, so the monster default data, and these will be the fields and the data that we're passing in. So for each of those, we're going to grab our start HP, the default missile, the attacker interval, the starting move speed, and we're going to assign them to the properties associated with our script. So we're going to grab all of these and cache them into our properties. We also have an isAlive flag set to true, so that when we initialize it, we are setting that isAlive flag to true. We also have the item drop rate, and this is going to determine the rate at which it will drop an item. If we have a must drop item value associated with this monster, then that means that it will always, at a 100% drop rate, drop the item that we set up here. And we'll get into how we set up drop tables in just a moment. Because if we look at the monster default data, we don't actually see a field to determine this must drop item here. So we'll take a look at where we get that from and how we utilize this property in just a moment when we get to that section. But for now, just know that this must drop item determines the item that will at a 100% drop rate be dropped by this monster. Otherwise, it will go based on this item drop rate and randomly spawn in an item. Moving on, in our find projectile manager that we call right here, we are going to, of course, grab our projectile manager and assign that to a property, and we're going to cache that to our property. And we're going to set our isAlive value to true. Next, in onUpdate, we're first going to do some validation checks to make sure the isStillPlay is true, meaning that the game is still running. If it's not, then we want to stop movement of our bats, and we don't want the bats to continue moving towards the player after the player is already dead. So we're going to disable the movement component of our bat. Then, if we're still alive and the game is still running, then we're going to first check if the movement component is false. If it is false, we're going to enable the movement component to make sure that the bat is moving. And then at the attack interval, so we're going to craft the delta timer and we're going to increment it by the frame delta. And if the delta timer is greater than the attack interval that we set up in our initialize, then we're going to fire our missile. So remember, for our bat's case, that will be 1.0 seconds. Then we're going to set the delta timer to 0 so that we can fire again every 1 second. Next up, speaking of fire missile, let's hop into that method. Again, some validation checks to make sure that the ProjectileManager exists, that we actually have the proper fields to spawn the missile in. And then we're going to, from our ProjectileManager that we'll get into, we're going to call the getMissile method that will return the entity of our missile based on the default missile property. So up here, we've set our default missile property based on the monster data that we passed in, and we're going to assign that to the missile entity here. If it exists, so this is another validation check. If it exists, then we're going to determine the fire direction. And then if the sprite render component is flipped, meaning that it's facing the other direction, then we're going to fire in the other direction. And then we're going to grab the monster position and we're going to set the fire position to the monster's position. And then we're going to call the fire missile method. And this is the same method that we called from the PlayerState. So we have also a fire missile method here. And this is that same exact method that we used here, but this time we're going to set the isShotPlayer property to false. So in our missile component, we have our fire missile that determines if it's been shot from a player or not. We're going to set that to false, and we're going to also pass in the direction. So our fire direction will be in the fire direction that we set up here, and then we have our fire starting position. Moving on, we have our send calc drop item. So this will be after the monster is determined to be dead and we want to drop an item, then we're going to utilize our ItemHelper that is going to have the method for calculating our drop rate. So we're going to get into this method in just a moment, but we have, inside of the ItemHelper, we have our calc drop item data method. And this is going to take in our drop rate, our must drop item key if it has one, and then the spawn position of our item. And the ItemHelper is going to handle the dropping of the item because our monster is going to be dead. And then we have our hit event, which is going to, as the name implies, detect when it's been hit. So first we're going to check if it's actually alive. If it's not alive, then we're not going to detect any more hits. If it is, then we're going to set the attacker entity to the attacker entity sent by the event. We're going to grab the total damage coming from our hit event, and we're going to grab the effect spawn position. We're going to decrement our current HP by the damage that's coming in from our event. We're going to play the effect based on the extra parameter that we grabbed at the effect spawn position based on the attacker's position. We're also going to play a sound when the monster is hit. And then if we have less than or equal to 0 HP, meaning that we have now died, we're going to set the alive property to false. We're going to call send calc drop item so that the ItemHelper can manage the drop information. We're going to play the effect of the death effect. We're going to increment our count kill score so that our game knows that we are one step closer to clearing the level. And then we're going to call entity service destroy. So this is going to destroy our entity. The reason why we are utilizing ItemHelper here so that we're not trying to execute a function after it's already been destroyed. So we're going to offload that to our ItemHelper, and we're going to call calc drop item data. And we'll get into that when we get into the item drops. But for now, just note that this method exists. So we mentioned that our monster's missile that is spawned every 1.0 seconds references the MissileData table. So let's actually look into the projectile systems and try to understand how this works, starting with this MissileData table here. So we already know that our missile ID has this ID that is referenced by other data tables, for example, our MonsterDefaultData, so that we spawn in the proper missile with the proper data So this missile bat has this model RUID associated with it. So if we go into our missiles, we have our missile_bat. If we double click that, we can see that this is the bat's projectile. We also have the attack value associated with that missile. So different types of missiles can do different amounts of damage. The missile bat just does one, but our player bullets and missiles do a lot more. We also have the move speed that the bullet will travel at, and we have the lifetime of our bullet. This is to make sure that our bullet doesn't keep going on into infinity if it doesn't have a target. And this is mainly for performance issues and performance considerations so that we're not keeping a bullet alive from our projectile pool manager that we'll get into in just a moment as we get into the nitty-gritty of the projectile missiles component. But this will ensure that after a certain duration of time, we are returning this bullet to the pool so that it can be recycled and reused in our pooling systems. Next, we have our hit effect RUID that will spawn the hit effect once it hits our target. And then we have the model RUID of the missile. So that again, for the missile bat, will be this model here. And we will copy the entry ID and paste that right into this model RUID field. Similarly, these other bullets, for example, from our character default data, we can also see that we have a default missile here, missile_bullet. So for our pirate, we are spawning this missile bullet. And if you double click the missile_bullet, we can see that this is the bullet coming from our player character. The player character's missile bullet, if we go up to our sprite render component, has the flip X property set to true, meaning that we have rotated the missile. So this is important in our fire missile methods that check for this property so that we are shooting and moving in the correct direction. So let's actually examine the components associated with our bullet. So let's double click our missile_bat bullet and let's take a look at the properties. We already know of the transform component and the sprite render component, and we'll collapse this again just so that we can take a look at everything in a bird's eye view. We have a lot less components compared to, let's say, something like our player. But in our bat, if you collapse this again, we have our transfer component and our sprite render component. We also have the trigger component, and here we have a different collision group. So we mentioned that our collision matrix determines which entities and which collision groups that our trigger component can interact with. And this will determine which entities with the trigger components set to the corresponding collision groups that it can interact with. So an entity with the player collision group associated with it can interact with items, it can interact with missiles, and can interact with monsters. So our missile can interact with skills and our player. With that understood, let's quickly review the combat flow before we move on to our projectile systems. So just as a quick review, the way that damage works in MapleStory Worlds is based on the attack component, the hit component, and the trigger component. So if we take a look at our documentation, we can see that we have our attack component that will spawn any given shape. So our attack component will be responsible for spawning our attack shape, and this will be the range that the attack should be registered in. So any trigger components that are overlapping in this range that have the corresponding collision groups that the attack component wants to target will trigger an attack. And the way we listen for those attacks and handle those attacks is through the hit component. So we can extend this hit component and we can create our own. And this hit component has the onHit method that is solely responsible for delivering the hit event to the various components. So we don't really have any custom behavior that we want to implement for our hit components. So we just keep the default one, and instead we listen in for those hit events through our event listeners associated with both our player and our monster. So our monster has a handle hit event and a player has a handle event as well. And each of our player components, so if we go into our player, we can see that we have a hit component. And this will be responsible again for detecting a hit, and our player state will be responsible for handling that hit. Same thing with our monster bat. We have our hit component, which will listen and detect hits and what happens after it's been hit. For our hit component, we have our collision groups. set to the proper collision group so that when our component is hit, or when our monster is hit, or a player is hit, that we are setting the proper collision group based on the matrix here. If our collision group is not set up to collide with the target collision group, so let's say, for example, a missile was not set up to target our monster, then that means that the missile and the monster will not interact and our hit component will not detect anything. So we want to make sure that our monster and our missile is both active so that we can detect hits on this monster bat. Same thing with the player. If we go into our hit component here and we open up our collision group, we can see that we have our collision matrix here set to our player. So our player has our player collision group so that our player can detect hits from missiles, it can detect hits from monsters, and it can detect hits from items. So make sure that we have the proper collision group associated with our player as well as with our monster. So I mentioned that generally there's an attack component that creates an attack shape where the hit component can listen in on damages. So the attack component will create the attack shape. The trigger component will detect the range for the damage, and the hit component will send the event and detect the damage. In our case though, if we go into our missiles here and we go into the missile bat, notice that we don't have an attack component here. And the reason for that is because in our component itself, we're going to be directly referencing the hit component and we're going to manually trigger that hit method on the target entity's hit component. So what the attack component normally does, we're going to manually do that from our projectiles. So with that understood, let's hop into our missile component and let's take a look at what it does. So let's hop back up to our component script folder and let's access our missile folder and let's double click the missile component to open it up. Similar to the other components, we can kind of see a pattern where we are passing in the corresponding data to our components so that we can initialize some values. So of course, with this missile component, we also have MissileData, and this is coming again from the data table here for our missile. This can be for our missile bullet coming from our player, or our missile bat coming from our monster. So we're gonna take in the MissileData. We're first going to, again, do some validation checks to make sure that the MissileData is valid. If it is, then we're going to set the various properties for that missile. So we have the missile ID that's going to store the missile ID column. We have the attack value that's going to be brought over from the attack value column, and so on. The move speed, the lifetime, and the hit effect RUID. We're going to cache all of that into the respective properties associated with them. Moving on, we have our return self that will be called when the missile is returned back to our pool manager. And this pool manager reference is going to be brought over from the projectile when it's spawned. So at the time of this missile being spawned in, it's going to have already a reference to the pool manager that is set by the pool manager. We're finding the pool manager for our missile because we're going to spawn it from the pool manager. And the pool manager itself is going to set this value because it has a reference to this entity. So knowing that, we're going to still validate and make sure that we have a pool manager. And otherwise, we're just going to destroy this entity. If it does, then our return self is basically just going to return our missile back to the pool. So we're going to call our pool manager's return missile method that will return our missile back to the pool so that it can be reused. Our onUpdate first has a validation check to make sure that is enabled, because our pool will disable this entity and its active state, whether it's enabled or disabled, will be the value that determines whether or not this entity is available for our pool manager to detect as something that can be recycled. So if our game is no longer in play, then we're not going to update anymore. Then if it is still running and the game is still in play, then we are going to grab our current transform and we're going to create our move vector. So this will be the fire direction set up here. So this will be the fire direction that we set down from our fire missile. So when we call fire missile, we're going to set up our fire direction and the other properties that we'll get to in just a moment. But we have our fire direction coming in from this fire missile method that's been set. And we're going to fire in that direction by the move speed from our move speed property set in our initialize, and we're going to set our transform value to the move vector that we've crafted here. Then we're going to check the timer. If our delta timer is greater than the lifespan that we discussed, then we're going to return the self. So again, this timer is set up so that it's returned to the pool after a certain amount of time so that the bullet doesn't just go off into infinity. And we can save performance by deactivating it after a reasonable amount of time and recycling the bullets. Moving on to the fire missile then. This is going to actually fire the missile, and it's going to set the delta timer to 0 so that we are starting from 0 until our lifetime before we recycle this bullet. We're going to set the fire direction in the direction that we'd like, whether it's -1 or +1 direction. We're going to set the isShot player to the proper value. So let's say, for example, in the monster state, when we call our fire missile, we have our fire direction that we are setting, and we're going to set whether or not the missile was fired from the player or not to true or false. So for the monster, it'll be false, but for the player, when we call fire missile, it's going to be true. Next, we have our fire starting position. So we're going to set the bullet entity or the missile entity to the starting position set by the fire missile. Then we're going to enable this so that we can start moving in the direction. And then we have our handle trigger enter events. So this will be the event that is called by our trigger. So when this trigger collides with a monster, and if this missile is shot by the player, then we're going to grab the trigger entity's hit component. And as mentioned, we're going to directly reference the hit component and we're going to call the on hit. So normally this would be done and handled by the attack component by creating an attack shape. But this time we're going to directly reference our entity by using our trigger and then grabbing the hit component, and we're going to call on hit directly. So on hit takes in the entity of the attacker. So the attacker, of course, will be the missile. We're going to pass in the attack value, which is set by the missile data in our initialize. And then we have whether or not it's critical. It'll always be false because we're not doing any critical calculations in this game. Then we have the hit effect RUID, which will be the attack info that we are going to spawn the hit effect with. And we're going to set the hit count, how many times we're hitting the player. And we're going to set the hit success boolean flag to true. So in this case, this will trigger our monster state's handle hit event. So because we are triggering the on hit of our hit component, the monster state's hit event will be fired and will be listened to by this monster state component. So down here, this is where we grab the event's extra parameter, and that will be the attack info parameter there. So we're going to grab the extra parameter to play that effect associated, and then we're going to deal the damage. For our player, so if the trigger has a player state component attached to it, and we detect that the bullet was not shot by the player, so we're going to make sure that this missile does not attack itself or the player. And then we're going to grab the hit component again, and we're going to check if the player is alive and that the player is not invincible. So remember that our player, after it's been hit, we're going to set the invincibility to true for a certain amount of time so that our player stays invulnerable to damage after it's been hit for the first time. And then we're going to set our hit success boolean value to true. And then if it's been successfully hit, we're going to return this back to the pool. Now let's finally take a look at our ProjectileManager that actually handles this pool. And let's take a look at how this is done. So back into our maker, let's open up our components and go into our in-game manager folder. And let's take a look at our ProjectileManager. So let's double click to open this up. Let's walk through the functionality of our ProjectileManager. So again, our ProjectileManager is going to work with various different pools. So we have a property up here that keeps a cache of the ongoing pools, and this pool will be accessed by the missile key. So whether this is a projectile for the monster or a projectile for the skill or whatever fired this missile, and of course that will be determined by the missile ID, whether it's a bullet, bat, or a missile. And the missile is the skill missile. But regardless, it will hold a different pool for each key. So if we dive into our getMissile method here, we can see that we are first checking if the projectile pool accessed by that key, and one more time, that is going to be that missile ID. If that projectile pool is nil, meaning it's not been initialized or accessed yet, then we're going to initialize that pool to an empty table. Then that will make sure that we always have a pool to grab, whether it's empty or if it already has values in it. We're going to grab that pool and cache that into a local variable. Then we're going to create a variable for the entity that we're going to search for in our pool, and we're going to set it to nil initially. And we're going to loop through all the items in our pool, and we're going to check if it's a valid pool, and we're going to check for if it's disabled. So we're going to do not enabled to make sure that the elements in our pool is actually disabled so that it can be reused. So if we have a valid entity and it's disabled, then we're going to just use that entity as the entity that we're going to return from our pool. So we have in our monster state, when we fire the missile, we have our get missile, and we pass in the missile that we want to fire. So our projectile manager in the get missile is going to search that pool. If it exists, then we're going to return that entity. However, if we don't yet have a pool of objects, and this of course will be the state that our pool will be in when we first start the game, because we don't have an active pool yet. In that case, we're going to spawn in the model ID and we're going to initialize the missile. So we have the DataTableLogic get MissileData by missile ID and pass in the missile key that we want to spawn in. That is going to return from our DataTableLogic, so this will be the data manager, and we're going to use the get method that will take in this key and retrieve the table entry that is crafted by this row here. From that, we're going to call the missile component's init data and pass in the data. And we just saw in the initialize how we are initializing that data. And then we're going to, as mentioned, in the missile component, we're going to set the pool manager property to the self. So this will be this instance of the pool manager. Then we're going to set the entity's enable property to true so that our pool manager no longer tries to access this or use this as a valid entity for the pool. And then we're going to insert this entity into our pool table. If the entity is nil, then we're going to spawn the entity in. That means that we haven't found it from our pool. But if we have found the entity from our pool, then we're just going to simply enable it. We also have a return missile method that will simply just set the enable property to false. So if the missile exists, we're just going to disable the entity so that it can be used by the pool again. So returning quote unquote the missile doesn't actually remove it or re-add it to the projectile pool. It instead just activates or deactivates, and that's how the pool determines whether this item is ready to be used or not from the pool. But regardless, every time a missile is spawned, it will be added to the projectile pool. Just the usability will be determined by the enable property of our entity. Reset pool will loop through all of the entities in our pool across all pools. So this will be every entity that is spawned in will be spawned in as a direct child of our current entity. And it will loop through all of the children of our entity, and we're going to set the enable to false. So it's effectively going to reset all entities in our pool. We have a special property for our get projectile skill that will take in our skill key, and it's going to behave in the exact same way, except rather than spawning a missile component entity, it will instead spawn a projectile skill component entity. But the structure of the get method will be pretty much the same. We're going to use the same pool structure, and we're going to add it to the same projectile pool table by the key, but instead we're going to utilize projectile skill component rather than the missile component. So now that we have an understanding of how the projectiles work and how the projectile manager spawns and manages these different pools, let's actually see the pool in action and play our game. So let's press play. And let's click start game. And if we open up our in-game here, we can see our projectile manager, and we can see that our bats are spawning in these different projectiles. And because there's a lot more bats, we can see there's a lot more projectiles. But if we start firing our projectile, and if we scroll down, we can see our missile bullet is our projectiles. We can see that no more than 2 is being spawned in. So we can see that despite the spawn button or our fire button being pressed a lot of times we only have 2 bullets that are being in rotation from our pool. And despite there being quite a bit of bats and a bunch of missiles being spawned from those bats, we only have a handful of missiles. And with that many bats and that many times our bats have been firing, there should be a lot more. So in this way, we are reserving and we're kind of saving space and calculation by utilizing pools. So from our projectile manager, I mentioned that there is a special method for retrieving the projectile skill. And that is because the skill projectiles utilize a special component called the ProjectileSkillComponent to manage the missile. Our skill missile will behave a little bit differently from our regular missiles because when it's being fired, it also has to block different projectiles. So when the enemy bats fire a projectile, this big giant skill missile will block all of those projectiles and return all of those back to the pool. And it will also continuously damage the monsters while the monsters are in range of the missile. If we hop into our skill folder, we can see that we have that component right here. But again, before we dive into this component and its functionalities, let's first again hop into our skill data and let's take a look at the data table for our skill projectiles. This is slightly different than our MissileData, as you can see, and we have a couple different data entries for our skill data. So first we have our skill ID. That will be the ID that identifies this skill, and that is used in our pool. So if you look at our pool for the projectile manager, that will take in the missile key for our skill, and that will be this skill ID. And that determines the pool that we're utilizing for our projectile pool. We have the skill type, which is the type of skill that it will be. This particular skill is a projectile skill, but of course it can have different functionalities. We have the isPierce property to true, meaning that it will pierce through everything. We have our attack value set to 20. We have our move speed set to 1. This will be the speed that the bullet moves in. We have our lifetime again for performance reasons to make sure that the bullet doesn't keep going on into infinity. And we recycle the pool after 5 seconds if it does not have a target. We have our max hit count, which is going to be the maximum number of times an enemy can be hit by this projectile. So I mentioned that this cannonball skill will deal continuous damage to the enemies as long as they're in range, but it will only do a maximum of 5 hits. After that, the enemies will ignore damage from this cannonball. Then we have a hit interval, and this is how often the enemies will be hit. And then we have the model RUID, and this will be the reference to the model here. So if we open up our models folder and enter into the skill folder, we can see that we have the skill cannonball model. And if you double click that, here is the model. This model has the projectile skill component, it has the trigger component, and it has the collision group of skill. So if we open up this matrix here, our skill does not interact with anything but our monster and the missiles. So it's very important for performance reasons to make sure that you are not unnecessarily triggering or interacting with collisions groups that you don't intend to. So a common one is the default that is just set to interact with everything. But for us, we have disabled everything from our default and for our trigger box. Returning to our skill data table, the final column is our hit effect RUID, and this will be the effect that we want to spawn once the enemy or the target is hit by this projectile. And let's review one more time the data flow again. So if we go into our logics and we go into our data table logic, we again have our skill data table here, and we have our initialized skill data that we are utilizing to grab the corresponding table, and we're going to loop through and retrieve all of those columns as data, store them into a table, and cache them into a skill data table property by the skill ID. We're going to be able to retrieve that skill data through the get skill data by skill ID, and this is going to be taking in the skill ID and then return the corresponding skill based on that ID. Now that we've got that, let's open up our projectile. So let's go back into our component script, open up the skill folder, and double click to open up our projectile skill component. In here, we again have our init data, and this will be set by projectile manager. So we have our init data that we're going to grab from our data table logic that we just saw. And we're going to, based on that data, we're going to set up all of the properties that are coming in from that data table. So the attack value, the hit interval, the max hit count, etc., etc., etc. We also notice that we have a delta timer property for determining whether to destroy or recycle back to the pool this missile if it does not have a target. The determination of whether it has a target or not will be determined by whether it has been hit last or not. So we'll take a look at that in just a moment. We also have a colliding table here, and this is to keep track of the entities that have been hit by this projectile. So remember that we only want to hit any given entity hit by this projectile a given number of times based on the max hit count. So if you go back to our data table, that max hit count is 5. So after 5 times of being hit, we no longer want our enemy to react to this skill. So we're going to keep a collision table of all of the entities that have interacted with this projectile, and we're going to keep track of how many times it's been hit. So that table is managed by our get or create collide entity here. So this method is going to take in the entity that it collided with, and it's first going to do a quick validation check to see if it is a valid entity. And if it is, we're going to grab the ID of the entity. Then, based on that ID, we're going to check our collision table to see if it's a valid entry. If it does not yet exist, then we're going to create the new collision table. Based on the entity ID, we're going to initialize the values of the target, which is going to hold a reference to the entity that it collided with. The hit count is going to be set to 0 because we have not hit the entity yet. This is going to be managed after it's been returned. And then we have the last hit time set to 0. So this won't have a track of the last time it's been hit yet. If it does exist, or if it's just been created, then we're going to return the collision table based on the entity ID. We have our apply damage method next, and this again is going to do a quick validation check to see if the data for our damage, and this is going to take in the table that we created here, our collision table. We're going to check the check data target value, so the entity that collided with this entity. We're going to check if it's valid. If it's not, then we're going to set the collision table to 0, meaning that this entity no longer exists. We're also going to do a validation check for the monster state. So this particular projectile is only going to collide with the monsters. So we're going to grab the monster state of the target, and we're going to check if the target is a monster by checking if it has the monster state component. If it does, then we're going to reference the hit component of the target, and we're going to call onHit. So remember, our missile component directly references the hit component and calls the onHit method rather than having it go through the attack component. So in our projectile skill component, we're going to do the same thing. We're going to reference the hit component, and we're going to call the onHit method. Then we're going to set the last hit time of this collision table to the elapsed seconds of the utility logic. So this will be the current total number of times since initializing the current world. Then we're going to increment the hit count. Next, we have the onUpdate. In the onUpdate, we're going to do a quick validation check to make sure that we are still playing the game. And if it is, then we're going to move our projectile by the frame delta. So in our move, we're going to craft our move vector based on the fire direction. And this fire direction will be brought over from our fire skill. And we saw this pattern before in our missile component. In our fire skill, it's going to set our fire direction, and then it's going to set the position to the starting position that we pass in. So here we have our move vector based on that fire direction, and we're going to move in the move speed that we set in our initialize. And this will be coming in from our skill data. Next, in our onUpdate, we have our run live timer. So this is going to check if our delta timer is greater than our lifetime. If it is, then we're going to disable this entity and return it back to the pool because it's been fired. It has done its thing, and we don't want it to be active anymore. So disabling the entity will return it back to the pool because our pool manager in our projectile manager checks for the enable status for grabbing things from the pool and utilizing them. Next up, we have the various events that we're listening in on for our projectile skill component. We're first going to, in this section, we're going to be detecting the missiles because we want our skill to block all the incoming missiles from the enemies. And if we detect that the trigger body entity is a missile component and the missile has not been shot by the player, then we're going to return the missile component to the pool, effectively kind of destroying it or blocking it from reaching the player. Then if it's not a missile component, then we're going to assume that it's a monster by checking for the monster state. If the monster state component exists on the trigger body entity, then we're going to assume that it's a monster. And then we're going to create the collision data, as we saw before, to keep track of the hit count and the last hit time. And then we're going to do a validation check for our collision table, make sure that it exists. And if the collision table's hit count exceeds the max hit count, again, this value should be 5 for our cannonball, then we're going to do nothing and return. Otherwise, if we have not hit the enemy yet, then we're going to just simply apply the damage right away. Otherwise, if we've already hit the enemy one time, at least one time, then we're going to check for the difference between our current time and the last hit time and see if that exceeds our hit interval. If it does, then we can now hit the enemy again. So the enemy can only be hit every 0.2 seconds. So if that's the case, then we're going to apply the damage. Next up in on handle trigger enter event. This will be when the entity enters into this trigger for the first time. The handle trigger state event will continuously be called as long as the triggers overlap. The trigger enter event will only be called the first time the two triggers overlap. We're going to do a validation check to make sure that our event is valid. And then we're going to first check for the missile component. If it's a missile component and it's not shot by the player, we're going to return self, similar to the way that we did with the trigger stay. And again, very similarly, we're going to check for the monster. And we're going to create the collision matrix or get it. And we're going to check if the hit count exceeds the max hit count. If it does, then we're not going to apply any damage. Otherwise, we're going to apply the damage. And then finally, we have our handle trigger lead event, again, another validation to make sure the event is valid. And then we're going to grab the collision table for the triggering entity's ID, and we're going to set the last hit time to nil. So the handle trigger enter event is called when the entity leaves this trigger range. So if it left this trigger range, then we're going to set the last hit time to nil. So I mentioned that monsters can drop items at a certain rate, and we're going to get into that in just a moment. But before we do that, as usual, first let's take a look at the item data. So let's open up our item data table. And in here, as usual, we have the item ID column identifying our ID of the item. And we also have the value type here. So the value type, if we remember going back to our player state, we have our applied item method. So in this method, we have the ability to set or increment our properties. So remember, we access the self like a table, and we are directly referencing by the name of the property as a key to the self and retrieving that property without referencing the name. So here we are referencing the property and we're increasing that by our number value. So depending on the value type, if it's a 1 or a 2, will determine whether it will increase the number or it will set the string. So here we have a value type of 1, we have our stat name of current HP, and we have a number value of 1. So what this will do is it will set the current HP property, which is right here. It will set the value type to 1. So this will be a number that will be increased. It will set the number value to 1. So it will increment our player health by 1. Conversely, for a value type of 2, for example, our change missile has a value type of 2, and it's going to affect our player stat of current missile, and it's going to set the string value to missile_missile. So this is going to be intended to swap out the missile that is fired when you fire the missile. And missile_missile, if you look at our missile data table, has a little bit stronger attack value than the normal bullet. So going back to our item data table, this then will set our current missile property to missile_missile. And we can see that taking place right here. Moving on, we have the sprite RUID, which is going to be the ID of the icon that will be spawned, or that will be set by our item. And then we have our gain effect, which is going to be the effect that is played when we gain the item. We also have another table here. Notice that we don't have any drop rates associated with this item data table, and that's because they are collected in a different data table. So let's take a look at that data table here. Open up ItemDropData table, and this will contain the drop rates for our various items. So here we can see that Life Recover has a drop rate of 20, and so on for the other items. So we have different drop rates being set for different items. And at the moment, all of these have the same drop rates, but they can of course be modified depending on the balance that you feel is right. And then finally, we have our MonsterSpawnData. So we have our items, we have the drop rates, but inside of our MonsterSpawnData, we have the actual drop rates for our monster. So we have a drop rate of 0 for our first bat. So our first bat will never drop anything. Our second bat has an 80% chance to drop something, and our third bat has a 100% chance to drop something, and that item will always be the item move speed up. And that is this item right here that upgrades the move speed by 0.05. So returning to our MonsterSpawnData now, we will, for stage 1, we're going to spawn 4 bats, and we have different parameters for our spawn information for our bats. So we're going to spawn the monster ID bat underscore 1, and we're going to have the XY coordinates to spawn the bat in. We have the entrance time, so this will be the number in seconds when to actually spawn this bat at this position. And then we again have the drop rate and the must drop item property. So each of these bats will have a different entrance time. They'll be spawned at different positions, and they have different drop rates. So with that in mind, let's first take a look at the MonsterSpawnManager, and then we'll take a look at the ItemSpawnManager. So let's go up to our in-game manager folder, and let's double click our MonsterSpawnManager here to open it up. And here we have two methods here. We have start game and clear all child. Start game is going to, as the name implies, start the game and spawn all of our monsters in based on the interval that we saw from our data table. We have our initial need to kill count being set up, and our game is going to be notified of this value after we spawn all the bats in. So after you spawn all the bats in, we want to notify the game. So the GameLogic init clear count is going to have the kill count, or the total kill count, after we spawn all our monsters in. Then we have our timer table, which is going to be initialized to empty, and we have our stage ID. So if the stage ID is 0, then we're going to set the stage ID to 1 and return. And then we have our validation check for our data. So we're going to pass in the stage ID, and we're going to return the monster spawn data, and we're going to validate that spawn data to make sure it actually exists. And then we're going to loop through each of the elements in that data table. And then for each of those elements, we are going to increment our need kill count by 1 so that the game knows that we have 1 more enemy to kill. And then we're going to start a timer. So this timer is going to be based on the entrance time property from our data. So this will be this entrance time property right here in seconds. So for each element in our monster spawn table, we're going to set a timer for our monster spawn and offset that timer by the entrance time. So after 3 seconds, 5 seconds, and 8 seconds, we're going to spawn in our corresponding monsters. Then for each monster, we're going to grab the corresponding monster data based on the monster ID. So that will be based on this ID right here, and it will be grabbing the data from our MonsterDefaultData table here. So once we get that data, we're going to create our monster, and we're going to spawn our monster in. We're going to pass in the monster data's model RUID, and then we're going to pass in the name of our monster. We're going to pass in the position based on our data. So this will be the spawn X and spawn Y positions. And then we're going to spawn it as a child of our MonsterSpawnManager entity. Then if that monster responds successfully and it actually exists, then we're going to set the position of the monster to the spawn position that we grabbed from our data. So from our monster spawn data, that will be the X and Y position here. And then we're going to initialize that data to the monster data, and we're going to pass in the data's item drop rate and the must drop item. So we saw earlier the init data method, and that's going to take in all of this data, and it's going to initialize based on the properties that we saw here. Once we have all of that, we will have our final kill count, and we're going to initialize our GameLogic with that kill count. So our game knows how many monsters to kill before we clear the game. Finally, for MonsterSpawnManager, we have the clear all child, and this will be for when we want to restart the game. This is going to loop through all of our childs, and it's going to destroy them. So all the monsters currently in the scene is going to reset and destroy all of those entities. And it's going to clear out any timers if any timers are still ongoing and monsters are pending spawn. We're going to clear out those timers so that they don't spawn in unnecessarily. Moving on, let's take a look at our ItemSpawnManager next. So let's hop back into Maker, scroll up to our in-game managers, and let's open up our ItemSpawnManager here. So our ItemSpawnManager has its own object pool. This is because we expect items to be dropped a lot, and following that same philosophy for items that you know or entities that you know will be spawned in regularly throughout your game, we want to utilize a pool so that we're reusing those entities rather than spawning new ones every time. So we're going to see a similar pattern to what we saw in our ProjectileManager for managing our item pool. And we can see our item model ID that we're going to utilize for our item. So we're going to use the same model for all of our items, and we're going to reuse that and set the sprite based on the data that we saw. So in our item data, we have our sprite RUID column here that will set the image of the item model here. So let's open up the item model and take a look. So if we open up the item folder and we can see this item object entity here, double click just to take a look at it. And you can see that we have our sprite RUID here. So from our item data table, we're going to grab our sprite RUID and we're going to set the sprite renderer component to that item ID. So this sprite will change out to the item data that we have set here. In this model, of course, we also have our trigger component, so our player can interact with this item. The trigger component has the collision group set to the item, and if we look at the matrix here, we can see that this item only interacts with the player and nothing else. So again, always a good idea to make sure that your collision matrices are set up to only collide with the entities that it needs to collide with to save on performance calculations at runtime. So returning to our ItemSpawnManager, when we create an item, we're going to first double check to see if our pool has been initialized yet for that item key. If it has not, then we're going to set and initialize it to an empty table. We are then going to grab the object pool, and it will always exist because we have initialized it up here. So it'll at least be an empty table. And then we're going to set the entity that we find to nil because we're going to search through it in here. And we're going to loop through if our pool is greater than 0. We're going to loop through each item in that pool. If it's not enabled and it's valid, then we're going to set the return entity to that pool item. We're going to enable that item in the else condition because we have found an entity here. And then we're going to grab the item component, call initData on that component, and we're going to pass in the item data. And then we're going to pass in the spawn position of that item data. If the item does not exist in the pool, or if the game has just started, of course we won't have a pool yet, it's going to start building up, we are going to spawn in our model. And typically with object pools, it's a good idea to spawn items in advance so you're not spending runtime calculations to spawn in your items. So you'll have a rough estimate or an idea of how many models you will actually need in your game and spawn those entities in advance so you don't have to spend extra calculations at runtime spawning these models in. But for sake of simplicity and ease of understanding, we're just going to spawn them at runtime. So we're spawning again as an as-need basis. So because we don't have any entities in our pool yet, we do need this entity. So we're going to spawn this entity in based on the item model ID. And this will be that model ID that we set up right here as a property. We're going to set the name and the spawn position and set the parent as this ItemSpawnManager. So we're going to, similar to our ProjectileManager, we're going to set the items as a child of this entity. We're going to set then our item components pool manager to the self, and this is a very similar pattern to what we did for our missile components. Our item component also has a reference to the pool manager, so we're going to set that at the time of spawning, and then we're going to enable the item so that it does not track and be checked for use when it tries to create an item. Then we're going to insert that item into the object pool based on the item key and pass in that item that we spawned in. The return item entity is going to just disable the entity, effectively returning it back to the pool because our pool checks for enable status. Moving on to the item component itself, let's hop back into our maker, go into our item folder, and let's double click to open up our item component. So in our item component, remember that we have our init data that was called from the ItemSpawnManager when it was spawned in, or reused from our pool. So we're going to init our data to the item data. So we're going to set the corresponding properties of the items to the data that we're being passed in. So we have our image sprite render sprite RUID property set to our item data sprite RUID. So what's happening here is that we have a reference to our sprite render right up here. And here we're going to grab the actual sprite renderer component from our entity and associate that with our image sprite renderer property. Again, in our model, we're going to be grabbing this sprite renderer component entity, and we're going to be manipulating the sprite RUID property to the data that we set from our item data. So that will be this sprite RUID here. So that's what we're doing in this line. And then the rest, we're going to be caching the values coming from our data table. So that would be the value type property, the target player state name, the number, string, gain effect, and spawn position values. And then if the item hasn't already been enabled, then we're going to enable the item. On the on update, we're going to first double check again, some sanity checking and validation checks to make sure that our entity is actually enabled and that we don't activate the rest of this logic here if it's not enabled, meaning that it's kind of in the pool and not ready to be used yet. We're also going to double check the game is still in play, and if it is, then we're going to check the item delta timer, and this is going to be similar to the missile projectiles. We have a lifetime value that we have set here as a fixed property. So this time it's not coming from our item data here, whereas the missiles did. This one is just going to be fixed from our item component here. In our on update, we're going to check if the accumulated delta timer is greater than a lifetime, and if so, we're going to return self, which will deactivate our entity by returning it to the pool. So we're going to do pool manager, return item entity, and we're going to pass in our self entity. If there is no pool manager, we're just going to destroy this item. While it's not counting the delta timer against the lifetime, we're going to be moving the entity. So we're going to be moving the item at a direction of -1 in the X. So it's going to be moving left at a move speed of 3.0. And this is just fixed from our component property. And we're going to move our transform position by that amount. And then finally, we have our trigger enter event. So this is going to be, again, triggered the moment our collision boxes overlap. So if we have a trigger body player state, if we know that the entity has a player state component attached to it, then we know that it's a player. So this is how we're checking for if it's a player or not. Then we're going to call the player state's applied item method to apply that item to our player. And then after we apply the item, we're going to return self so that we return this item entity back to the pool so it can be reused again. Finally, we have our ItemHelper that will actually calculate and utilize the drop. So let's hop into our helper folder here, and let's double click to open this up. So our ItemHelper has a calculate drop item data. So if we go back to our monster state here, when the monster is defeated, we can see that we have the send calc drop item method that is being called. And in that method, we are calling the ItemHelper as calc drop item data here. So our ItemHelper is going to execute the calculation for the drop and actually drop the item. So we're going to first check the item drop rate and make sure that the drop rate is a valid number, meaning that it's non-zero and it's non-negative. We're also going to check if the item drop rate is greater than or equal to 1, meaning that it will always drop an item. Otherwise, we're going to calculate a random value and check that against the item drop rate. So if our random value is greater than our item drop rate, then we're not going to drop anything and we're going to return. Otherwise, we're first going to check if we have a must drop item key. And again, this is an item that will always be dropped 100% of the time. If that's the case, then we are going to make sure that we always drop this item specifically. So we're going to grab the item data based on the key, and this is going to come from our DataTableLogic. And we're going to use the get method corresponding to the item key. If that data is valid, then we're going to call sendSpawnItem, which is actually going to spawn the item in. Let's get into that in just a moment, but continuing on in our drop method here, we have our drop data here that's going to come from our getItemDropData table. So this is going to get all of our item drop data here from our drop table, and we're going to loop through all of those, and we're going to calculate the total value. So this is going to be the total value of all of the items drop rates. So if we go back to our table, we have the item drop data. We're going to loop through all of these and we're going to add up the total. And then we have our random value. That's going to be a random integer range from 0 all the way up to our total value. So it's going to be a random value between 0 and the total of all of these values here. After that, we're going to calculate the result value at each step as we loop through the drop data table. We're going to add from 0 the current drop rate. And if our random value falls within that range, then we're going to find the item based on the item ID. So that will be this field here. And we're going to grab the item data, which will be the item data here. If that exists, then we're going to call spawnItem, and we are going to actually spawn that item in. Otherwise, we're going to do nothing in return. So actually spawning our item in, we're going to first double check to make sure that we have an ItemSpawnManager attached to our ItemHelper. And then we're going to call createItem on the ItemSpawnManager. So remember, the createItem will utilize a pool to spawn our item in. Next up, we have our initialized data. So first, we're going to check for the ItemSpawnManager. If the ItemSpawnManager does not exist yet, then it's going to grab the ItemSpawnManager from the corresponding path. And then once we found that entity, we're going to cache the ItemSpawnManager property with the value that came from our getEntityByPath. And we're going to grab the ItemSpawnManager component from that find entity. And then finally, we're going to call releaseData, and we're going to release the ItemSpawnManager to nil so that we're not trying to spawn items, let's say, for example, in the title screen. All right, and with that, we've covered all of the major gameplay-related scripts in our game. The last set of components and the last set of scripts that we want to go over is related to the UI. We've already gone over that the UIManager is going to act as the communicator between these components and the callers that affect these UI components. But let's dive into each component and each UI in detail. Let's start with the title UI. So let's hop over into our UI editor by clicking on this button up at the top. And let's select the title UI group. And the first thing you might notice immediately is that instead of the actual text, we have this kind of special syntax here. We have the UI underscore title, UI underscore how to play, and it almost looks like an ID more than it does actual text. So this is because we are utilizing localization. So these are localization keys that we are accessing from our string table. So if we open up our string table data here, we can see that we have the key, which is UI underscore title, that we saw from our title. Let's go back. And we saw UI underscore title. We have UI underscore how to play. And UI underscore how to play has the source text and the Korean and English version of those texts. So inside of our title UI, if we go back to our scene, we have our title frame that has this text component. And if you look at our property, we can see the text is UI_title, and we have is localization key property. So this will make sure that our text component knows that this is a key for our localization system and not intended to be used as is. So this will go through our string table and pull the corresponding localized text. And with that in mind, we will open up our TitleUIController, and that is attached to our TitleUI group. So there's our TitleUIController, and let's find the corresponding UI controller, TitleUIController, and let's double click to open this up. So we have references to the various parts of our UI. So we have our start button entity, our how to play button entity, our exit how to play button, and our how to play window entity. And these are all buttons that we want to hook up, with the exception of this how to play window entity. Inside of a title UI, we can see that we don't have the references set up in our property inspector. Instead, in onBeginPlay, we find the entity by child name. So we're going to find the start button by name. So that will be this button right here. And we're going to get the child by name. If it exists, then we're going to set the start button entity property to the entity that we found. And to that entity, we're going to use the syntax called connect event. So this is essentially going to create a listener for our event. So similar to the way that we have set up listeners for taking damage in our PlayerState component. So we have our handle hit event that we're listening in on, and we're handling by when the event is sent to our player. With this syntax, we're doing basically the same thing. We're listening in on this button click event whenever it's being called, and we're going to pass in the method that we want to handle that event. So we're going to pass in the showSelectCharacterUI property, and that is going to be the method that we call when this button is clicked. So when the start button entity, and that will be this start button here, when that's clicked, then we are going to show the SelectCharacterUI. So we're going to call GameManageLogic and call SelectCharacterUI so that we can open that window up. So we follow this logic here. We can see in the Game Manager, we have a reference to our SelectCharacterUIController, and we're going to show it. We're also going to call the initialize function for that controller, but we'll get into that in just a moment when we cover the SelectUIController. Next up, we have our button how to play, and exact same syntax, except we will show the how to play window here. So hopping into this method, we will have a direct reference to the how to play window, and we can see that we have the reference here, and we are setting that reference at runtime here by directly searching for the child by name. So that will be the how to play window, and that will be this window right here. So when the how to play button is clicked, we will call this method that will enable this how to play window. We have the exit how to play button, which will be this button right here. When that button is clicked, we are going to call hide how to play window, which is just going to be the opposite of the show how to play window. And it's just going to disable our how to play window entity. Speaking of the SelectCharacterUI, let's move on to the SelectCharacterUIFrameController. So let's hop into our SelectCharacterUI. So let's go to our UI groups and let's open up the SelectCharacterUI group. And under here, we have in the properties, we have the SelectCharacterUIController attached to this root. And we can see that we have a property for our SelectFrameID. And the reason we have this property is because we will be spawning in each character at runtime. So remember in our character default UI data, we have different characters for our characters. And the character select UI data is going to have the character ID, the localized name ID, and the sprite RUID for our character. And depending on the values in this character UI data, that will be what we actually spawn at runtime into this table. In our select character UI, we have this model here, and this model is actually this select character frame. And if we double click this, we can see that there is that UI that we saw in our character selection screen. So this, of course, is variable depending on the character that we have set up. So we have to set up both the character select UI data and the character default data. So with that in mind, let's actually open up our CharacterUIController and take a look. So in onBeginPlay, we are going to find our scroll rect, and that will be the scroll rect for our CharacterSelectUI. So if we go back into our scene and we activate our UI, we can see that we have a scroll rect here that is going to be dynamically create a scrollable UI depending on the number of entities in the scroll rect. So if we have more than what is visible on our window here, we will be able to scroll through, and this will automatically adjust the scroll bar so that we can scroll through our different characters. So this is a great way for things like a character select window or an inventory window where we know that we'll have more items on our UI than is actually visible on screen. So we're going to grab our scroll rect and we're going to cache that into our scroll rect property right there. Then in our init character select frame right here, remember in our UIManageLogic, we call the show method as well as the init character select frame here. So that is this method in our character select UI controller right here. We're first going to grab the player data. So that will be the character select UI data table, and that will be this data table right here. The pirate and the localized name ID and the sprite RUID, that will be the data that we're going to be loading in. We're going to loop through all of those data. Of course, we're going to do a validation check to make sure that it exists and it's a valid data. But if it is, then we're going to loop through each of those entries in this table, and we are going to first spawn the character select frame because we want to have that character as a selectable character. And then for each of those, we're going to set the character select frame table that we have up here to the entity. We're going to grab the character select frame controller and init that controller with the character UI data. So we'll get into the character select frame controller, but the init character UI data is going to actually set the sprite with the sprite RUID, and it's going to update the text by the localized name ID. When we call show, we're going to enable our window. When we call hide, we're just going to simply disable our window. And that's it for our select UI controller. Next, let's move on to our select frame controller. So this will be the entity that is actually spawned into our UI in this field here. So our character select frame, if we check the properties, we can see that it does have the character select frame controller attached to it. So we'll double click to open this up. And inside of a character select frame controller in onBeginPlay, we're going to call our initialization function. And these are going to set up each of the UI elements for our character select controller. So we have our text component property. So we have our character name component. That will be this item right here. So we're going to grab the name text, and we're going to assign the text renderer component to the character name component so that when we initialize our data based on the init character UI data, that we can set the name and the text property for the character name. We also have the character sprite that we're also going to search for by the name, and that will be the icon right there. And we're going to cache that into our property up here. Finally, same pattern, we're going to search for the start button, and we're going to connect this button to the call teleport in game method. And that will set up our character with the select character key that we are going to pass in from our init character UI data. And that will be initialized up here from our character UI data. And we're going to teleport the player into the game based on the name of the scene. So that will be the in-game scene. Moving on, we have the show method that will just set the enable property of our entity to true and the visibility property to true. Conversely, we have our hide that will set the visibility to false and our enable property to false. And then from our character select UI controller, we had passed in the data that we loaded in from our DataTableLogic for our character select UI data table. And we are going to initialize our character select key to the character ID of our character UI data. So this will be the property for right there, the character ID column of our character select UI data. And then we are going to set our select character key to that character ID so that when we teleport, we can initialize our character with the proper character. And then we're going to set the text value to the localized version based on our table key. So that will be this value here. We're going to grab the localized copy. And then finally, we're going to set the image RUID to the sprite RUID from our data table. Next up, we have our default UI. So this will be the UI, and we'll open up our scene here. And let's select our default UI right there. So this will be the health icons, the skill icons, the auto skill icon, as well as our mobile controls for attack and our skill and our movement that you didn't notice while we were playing our game our first time because we were playing from our PC. But if we press play, and first we'll set our PC to mobile. And if we press play now and we start the game as the pirate, we can see that we now have our mobile controls active here. And we can fire, and our button is properly connected to the fire. Our skill is properly connected to the fire. And we can play as normal, considering our mobile controls. So returning to the UI then, these buttons are only visible when we are in mobile mode. And the reason for that is if we go into the property, we can see that the active platform field of our UI transfer component is set to mobile. So any entities with the UI transfer component type that is set to the mobile will only be visible when the platform is detected as a mobile platform. So the auto attack button is set to all, meaning that this will always be visible for all platforms. Same thing for the info frame containing our health icons and our skill icons. This is set to all. But our skill button and our attack button are both set to mobile as the active platform. So this will ensure that the icon and the move button is only visible in the mobile platform. In our default UI, we have our default UI controller that controls all of these items here. The auto, these buttons down here, as well as the life icons and the skill icons. So let's take a look at the default UI controller and see how all of this works. So in our onBeginPlay method, we have various init methods here. So this will be initialized methods for different parts of our UI. So our life UI, our skill UI, our auto entity, our attack button, and our skill button. We have individual initialized functions for each part. So if you take a look at our init life UI entity, we can see that we are first checking if the UI entity table is valid, or is not valid rather. Then we're going to search for the live text, and that will be this entity right here. And then we're going to find each children, and we're going to set the live UI entity property, and that will be a table of all of these live entities here. And we're going to set that to the child entity based on the index. We're going to do the same thing for our skill UI entity, and it's going to follow the same pattern. We're going to grab the corresponding skill text entity, and that will be the skill text entity right here. And we're going to loop through each of these children, and we're going to grab that and set that into a key as the reference to the skill entity. The init auto entity is going to set and find the auto attack button and set the corresponding property in our property inspector. And it's going to connect the auto attack button to the change auto fire method. So we have our change auto fire method right here, and that is going to call GameLogic, and it's going to call the need auto fire. And if you go, just as a quick reminder, this is simply going to set and toggle the need auto fire flag from our GameLogic so that our auto fire from our PlayerState knows to automatically fire projectiles rather than manually pressing the button. And then once we change the auto fire, we're going to update the auto UI, which is simply going to set the sprite image RUID to either the auto sprite RUID or the manual sprite RUID. And that is set from our inspector here. So if you go back up into our default UI, we have two properties set from our inspector. And these are two different UIs depending on if it's currently in the auto mode or if it's in the manual mode. Returning to our initialize steps here, we have the attack button and the skill button. And this is going to follow a similar pattern. We have the attack button that is going to find the local player, and it's going to grab the player state of our local player. And if that player component is valid and it exists, then we're going to connect the attack button to the player component's fire missile method. So remember from our player state, we have our fire missile method that is going to fire this missile out. So whenever our button is clicked, we're going to call the fire missile method from our player component. Similarly, for our skill button, we're going to do the exact same thing. We're just going to find the entity, and then we are going to grab the PlayerState component and connect the skill button to the fire skill method of our player component. And that's our default UI. The final UI that we're going to talk about is the ResultUIController. So if we open up our scene again and we swap to the Result UI, this will be either clear or fail, and that will be set by the Result UI. And then once we show this Result UI, it will kind of tween from this position down to the center position. And we have our UI retry and UI exit buttons hooked up to the corresponding methods. So if we open up our Result UI controller, we have a very similar pattern to our default UI controller. And all of this should be fairly self-explanatory to you by now and hopefully very familiar to you. But we're going to grab our result entity, and we're going to grab our result sprite. We're going to grab our retry button and the exit button. And for the retry button, we're going to connect our onClick retry button method that's going to call GameLogic and call the restart game of our GameLogic. For our exit button, we're going to call clear object pool, and we're going to return the player back to the title. We also have our shell method that is going to set the retry and exit button to false. And then we're going to grab our tween line component from our result entity. So our result entity has a tween line component here. And depending on the type of tween here, it's going to have a different animation. So here, we're going to just simply play the tween line component based on the settings that we have here. And then after 1.5 seconds, we're going to re-enable our retry button and exit button. So after our result entity has appeared, then we are going to enable the retry button and exit buttons. Finally, in our hide, we are simply going to stop the tween line component, and we're going to set the enable property to false so that we no longer see this result UI controller. And that's all I have for you today. Thank you so much for exploring this project with me and its features. I know this was a long one, but hopefully it'll serve as a reference guide for anyone looking to start a game in this genre. Again, keep this video handy as a reference for you to return to different sections of the world scripts and features so that as you develop, if you forget what any of these do, you can return to these at a later time. Thanks again for joining me, and I can't wait to see what you do with this project. Happy creating!